Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 32 to the power of x is equal to 16. So what I'm first going to do is I'm going to rewrite 32, because 32, this is equal to 2 to the power of 5. So now if I substitute in 2 to the power of 5 for 32, I get 2 to the power of 5 to the power of x is equal to 16. Now, if 32 is equal to 2 to the power of 5, then this means that 16 is equal to 2 to the power of 4, because 32 divided by 2 is 16. So now, I'm going to rewrite this as 2 to the 5 to the power of x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 5 to the power of x, that's going to equal 2 to the power of 5x, which is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 5x is equal to 4. Now to solve this, I'm going to divide both sides by 5. So then these two cancel out. Now I'm left with x is equal to 4 over 5. So this is my answer. Now, to check, my original equation was 32 to the power of x is equal to 16. So I know that x is equal to 4 over 5. So now I have 32 to the power of 4 over 5 is equal to 16. Now remember how 32, this is equal to 2 to the power of 5. So if I substitute in 2 to the power of 5 for 32, I get 2 to the power of 5 to the power of 4 over 5 is equal to 16. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 5 to the power of 4 over 5 is going to equal 2 to the power of 5 times 4 over 5. And 5 times 4 over 5, these two cancel out. So I'm left with 2 to the power of 4 is equal to 16. And 2 to the power of 4 is equal to 16. So I have 16 is equal to 16. And because this is right, my solution here is right as well. Alright, so our problem here is 5 to the power of x is equal to 6. So right now, just simply taking a glance at this problem, I know that x here, this is going to be a decimal, because I know that 5 to the power of 1, this is equal to 5, and 5 to the power of 2, this is equal to 25. And 6 is somewhere in between 5 and 25, meaning x is somewhere in between 1 and 2. However, x is a decimal, and it's really hard to just guess for a decimal. So, to find the value of x here, this is my solution. So, I first start with 5 to the power of x is equal to 6. Now, I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of x is equal to log 6. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So log 5 to the power of x, I'm going to do the exact same thing. And the reason why this property is so useful is because right now we have 5 to the power of x equals 6, and because we know that x is going to be a decimal, it's going to be really hard to find out the value of x just as an exponent. So now, as you can see, once we change the exponent x, once we make it go to the front, it's going to be a real term, and then it's going to be much simpler to solve for it. So I have log 5 to the power of x is equal to log 6. And now if I move x to the front, I get x times log 5 is equal to log 6. Now I'm simply just going to divide both sides by log 5. So then these two cancel out. And now I'm left with x is equal to log 6 over log 5. Now log 6, this is equal to 0.7781. And log 5, this is equal to 0.69897. So now if I divide these two, I get 1.113287. So this is my answer. All right, so I have 4 to the power of x is equal to 2 to the power of 3x. So I want to find the value of x here. Now, first off, 4, this is the same thing as 2 to the power of 2. So if I replace 4 with 2 to the power of 2, I get 2 to the power of 2 to the power of x is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is the same thing as 2x. Now this is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3x. Now, to solve this, I'm first going to subtract both sides by 3x. So then these two cancel out, and now I'm left with 2x minus 3x is equal to 0. Now, if I factor out x from here, I get x times 2 minus 3 is equal to 0. 2 minus 3 is negative 1, so now I have negative x is equal to 0, and if I divide both sides by negative 1, I get x is equal to 0 divided by negative 1 is 0. So my answer is x equals 0. Now to check, my original equation was 4 to the power of x is equal to 2 to the power of 3x. Now I know that x is equal to 0, so now I have 4 to the power of 0 is equal to 2 to the power of 3 times 0. Now 3 times 0 is simply 0 because anything times 0 is 0. So now I have 4 to the power of 0 is equal to 2 to the power of 0. Now any number to the power of 0 is simply equal to 1 besides 0 itself. So 4 to the power of 0 is going to equal 1, and 2 to the power of 0 this is also equal to 1. So I have 1 is equal to 1, and because this is right, my solution is right as well.